Good day everyone, welcome to my YouTube channel. So for today I'm going to discuss about asymptotes. So for our objective, be able to find vertical and horizontal asymptotes. What are asymptotes or what is an asymptote? An asymptote is a line or curve that describes the behavior of a graph. The two kinds of asymptotes we will be working with are vertical and horizontal. Types of asymptotes: for vertical, our x is equal to a. As you can see in our graph, we have here our value of a, or x is equal to a, and the given y equals the absolute value of 1 over x minus 1. So if our x is 1, meaning 1 minus 1 is equal to 0, our value for y is undefined. Therefore, that is our asymptote, x equals a. For horizontal, y equals b, we have here the red color, the broken line, that is our horizontal asymptote, given y is equal to x squared plus 4 over x squared plus 2. So finding a vertical asymptotes have an equation of x equals a, where a is a value that makes only the denominator equal 0. So we have here an illustration of the graphs. The red broken line here represents our asymptote, or we have here asymptotes, in which our denominator, when x equals negative 3, so the equation is undefined, meaning that is our asymptote, negative 3. And also if x equals positive 1, 1 minus 1 is 0, it becomes undefined, so that is our asymptote. The other one, we have 1 also is our asymptote. For example, let's now have example number 1. Find the vertical asymptote or asymptotes of the following, or of the function f of x is equal to quantity x minus 3 times quantity x plus 4 over quantity x minus 2 times quantity x plus 1. So for our solution, you just find the value of x to make the denominator equal to 0. So you can have x minus 2 equals 0. Solving for x, that is x equals transpose negative 2 to the other side, positive 2. This is our first vertical asymptote. For x plus 1, our value is x plus 1 equals 0. So transpose positive 1 to the other side, x equals negative 1. Therefore, there are two vertical asymptotes in the problem, which are x equals 2 and x equals negative 1. Another example, sample number 2, find the vertical asymptote or asymptotes of f of x equals x squared minus 1. So just take note, this is a rational function. You can have to solve the denominator, factor out x squared minus 4. So as the given, x squared minus 1 over x squared minus 4. X squared minus 4 has factors x minus 2 and x plus 2. So we have here solving for x, x minus 2 equals 0. So x equals 2. The other one, we have x plus 2 equals 0. So transpose positive 2, x equals negative 2. Therefore, our vertical asymptotes, x equals positive 2 and x equals negative 2. For example number 3, find the vertical asymptote or asymptotes of f of x equals x squared plus 3x plus 2 over x squared plus 9. So for our solution, solving the denominator, that is x squared plus 9 equals 0. So x squared equals negative 9, transpose positive 9, that is negative 9. Since negative 9 is not a real number, that is imaginary number,
Square
so
root of negative 9.
there is no vertical asymptote. Example number 4, find the vertical asymptote of g of x equals x squared plus 5x plus 6 over x squared minus 9. So x plus 2, the factor of x squared plus 5x plus 6, x plus 2 times x plus 3. And the factor of x squared minus 9, x plus 3 times x minus 3. So since we have the same x plus 3 in the numerator with the denominator x plus 3, we can cancel because that is equal to 1. So we have here the remaining is x minus 3. Therefore, our value for x, x minus 3 equals 0, x equals positive 3. That is our vertical asymptote. Okay, let's now have finding of horizontal asymptote. Horizontal asymptotes of function f of x have an equation of y equals b, where the limit of f of x equals b, where x approaches to infinity, or limit of f of x equals b, x approaches to negative infinity. We have here an illustration of the graphs. We have horizontal asymptote, this horizontal line here. We have 2, and the other one is, we have here our horizontal asymptote is equal to 1. The y is equal to 1. So example number 5, find the horizontal asymptote or asymptotes of f of x equals 3x squared over x squared minus 1. So we have here the technique on how to find immediately the horizontal asymptote. If both polynomials are the same degree, divide the coefficients of the highest degree terms. So since we have the same, numerator has 2 exponent, the denominator is 2. So the numerical coefficient is 3 and the denominator is 1. So therefore, f of x equals y equals 3 over 1, that is equal to 3. 3 is the horizontal asymptote. 6. Find the horizontal asymptotes of g of x equals 2x squared plus 4x plus 1 over 4x squared minus 3x plus 2. So take note, if both polynomials are the same degree or they have the same exponent, the highest degree, divide the coefficients of the highest degree terms. So we have our highest degree is 2. So you just copy the numerical coefficient 2 divided by 4. So y is equal to 2/4 or 1/2. Therefore, 1/2 is our horizontal asymptote. Number 7, find the horizontal asymptote of g of x equals 4x over 2x squared minus 1. If the polynomial in the denominator is a lower degree than the denominator, the x-axis, y equals 0 is the horizontal asymptote. So automatically, as you can see, if the numerator has only 1 or the lower exponent than the denominator, therefore automatically our horizontal asymptote is 0 or y equals 0. 8. Find the horizontal asymptote of f of x equals 2x cubed plus 4 over x squared minus 5. Take note, if the polynomial in the numerator is a higher degree than the denominator, there is no horizontal asymptote. So, as you can see, our exponent for the numerator is 3. For the highest degree of the numerator is 2. Since numerator exponent, the highest degree is greater than 2, therefore there is no horizontal asymptote. In summary, we will be working with two types of asymptotes, vertical and horizontal. To find a vertical asymptote, find where only the denominator is equal to 0, then solve for the value. To find a horizontal asymptote, find the degree. Again, in summary, if both polynomials are the same degree, divide the coefficients of the highest degree terms. If the polynomial in the denominator is a lower degree than the denominator, the x-axis y equals 0 is the horizontal asymptote. If the polynomial in the numerator is a higher degree than the denominator, there is no horizontal asymptote. Thank you very much for watching. Please don't forget to click subscribe on my YouTube channel for more videos.